Today we're going to talk about equivalent fractions. If you look at the word equivalent, you can see that it begins with the word or the same prefix as the word equal. What equivalent fractions are fractions that are equal. So 1/2 is equal to or means the same thing as 2/4 and 3/6 and 4/8. All four of these fractions are equivalent fractions. They name the exact same amount of the pie. Okay, you can see that in the pictures below each fraction. 1/2 of the pie names the exact same part as these 2/4 of this pie, which names the exact same part as these 3/6 of this pie, which names the exact same part as these 4/8 of this pie. That's what equivalent fractions are. So we have two strips that are the exact same size, and we're asked to shade the same amount in the second strip as in the first strip, and then write what fraction we have shaded in that second strip. Okay, so if the first strip is shaded to here, then my second strip has to be shaded the exact same amount, which would take 2 of those 4 equal sections. So this fraction that names this fraction bar would be 2 out of 4 parts would be shaded. Okay, that means that the fraction 1/2, which is what names this first bar, covers the exact same amount of space as 2/4 does. So 1/2 is equivalent to 2/4. They name the exact same amount of space in the diagram. Okay. So we have some more fraction bars. You can see how big one whole is. It goes from here all the way to here. Well, this shows us that one whole is the exact same thing as 2/2 or 4/4 or 5/5 or, those are not 6, 1, 2, 3, 4, 5, 6, 7, 8, or as 8/8, or as 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths, 10 tenths. And on and on and on. Okay, I could continue writing them all the way to the end. Okay, so if I were going to write the equivalent fractions then, I would say 1 is equivalent to 2/2, which is equivalent to 4/4, which is equivalent to 5/5, which is equivalent to 8/8, which is equivalent to 10/10. Look at those fractions that are all equivalent, and they're all equivalent to 1. They all equal 1. What do you notice about their numerator and their denominator? In each case, they are the same, right? Whenever you have a fraction that has the same number in the numerator and in the denominator, that fraction is always equal to 1. Let's name the equivalent fractions that are shown by each of these pictures. Okay, so I can look at this picture in a few different ways. So the first way I'm going to look at it is, well, I'm going to notice that there are 4 shaded parts out of how many equal parts altogether? 6. So one way to name this picture is 4/6 of this picture is shaded. But I can look at this picture a different way. I can group the shaded parts a different way to get a different equivalent fraction. So what if I look at it this way? I can make 3 equal groups if I look at it that way. And how many of those 3 equal groups are shaded? Well, 2 of those 3 equal groups are shaded. Okay? This one and this one. Okay, so 2 out of 3 equal groups are shaded. That means the fraction 2/3 is equivalent to 4/6. Okay, let's look at this one. I've got how many shaded pieces. Well, I've got 6 shaded pieces out of how many altogether? Out of 9, right. Okay, let's look at this a different way. Group the shaded parts differently. Well, again, I'm going to look at it this way. There's one group that is shaded. There's 2 groups that are shaded out of 3 groups altogether. So I have 2 groups that are shaded out of 3 groups altogether. 6/9 is equivalent to 2/3. Okay, look at this third one. I have 2, 4, 6, 8 sections that are shaded out of how many altogether? 12. But again, if I look at it this way, regroup it, I have 1 group that's shaded, 2 groups that are shaded out of 3 equal groups altogether. So 2 out of 3 equal groups are shaded. So 8/12 is also equivalent to 2/3. Okay, what about this one? 2, 4, 6, 8, 10 out of how many altogether? 15. So 10/15 is shaded. But again, if I regroup it, that is equivalent to 2 out of 3 equal groups that are shaded. So that is equal to 2/3 as well. You can see just by looking at each of these diagrams, the exact same amount, the exact same part of each square is shaded, right? So that means that our equivalent fractions, 4/6 and 6/9 and 8/12 and 10/15 are all equivalent fractions, and they are all equivalent to 2/3. Okay, so all 5 of those fractions are equivalent fractions. They name the same portion of that square that is shaded in each case. Well, let's see if we can figure out a rule for how we can get from 2/3, which we had on the previous page, to its equivalent fraction. One of them was 4/6. Okay, so how can we get from here to here? Well, the way that we do that is by multiplying our numerator and our denominator by the same number. Okay, so what did I have to multiply 2 by to get 4? What am I multiplying by? 2 times what? Gives me 4. Timesing by 2, right? So then if I've multiplied by 2 in the numerator, I have to do the exact same thing in the denominator. I have to times by 2 in the denominator. Okay, so whatever you multiply your top number by, you also multiply your bottom number by the same number. And when you do that, you will get an equivalent fraction. In this case, 4/6. Okay, so let's do that here. What have I multiplied 2/3 by to get its equivalent fraction, 6/9? Well, let's look at the numerator. What have I multiplied 2 by to equal 6? 2 times 3. So I've multiplied by 3 on the top in the numerator. That means I have to multiply by 3 on the bottom. 3 times 3 is 9, and that's how I get this equivalent fraction. Okay, so look at the third one. What have I multiplied my 2 in the numerator by to get an 8 in the numerator? 2 times 4. So then I have to do the same thing in the denominator. 3 times 4 as well. And that's how I got this 12, giving me an equivalent fraction, a fraction that is equal to 2/3. Okay, what about the last one? What have I multiplied my numerator, the 2, by to equal 10? 2 times 5. So I have to do the same thing in the bottom, 3 times 5. And I get an equivalent fraction, 10/15. For the pictures here of the pie, we're going to divide each piece into equal parts so that there's a total of 12 pieces, and then we're going to write the equivalent fractions showing our multiplication statement so that we can see how we're making those equivalent fractions. Okay? All right, so if my first pie is split into 3 equal sections, but I need 12 altogether. So I'm going to divide each of those 3 sections into how many pieces? 3 groups of 4 will give me 12. Right. Okay, so I'm going to divide that one into 4 equal groups, that one into 4 equal groups, and that one into 4 equal groups. Okay, now I have 12 sections. Okay, what did I have shaded at first? How many of those 3 equal parts were shaded? 2 of those 3 parts were shaded. Okay, now that I've redivided my pie into 12 equal parts, how many of those 12 are shaded? 1, 2, 3, 4, 5, 6, 7, 8. 8 of the 12 parts. Well, let's just have a look and make sure that 2/3 is equivalent to 8/12. The way I can check is I just say, okay, what have I multiplied my numerator by to get from 2 to 8? Times by 4. So on the bottom, check and see, have I multiplied 3 times 4 to get 12? Yes, I have. As long as I've multiplied my numerator and my denominator by the same number, I know that 8/12 is an equivalent fraction. It means the same thing. It covers the same amount of the pie as 2/3. Okay, so let's do the same thing with the second one. Okay, this time my pie is split into 4 equal parts. So how many sections will I need to split each of those up into in order to make 12ths? Right, each one will need to be in 3 sections, right? But first let's write how much of this pie is shaded. 1 part out of 4. Okay, now I'm going to divide each of those 4 parts into 3 equal sections so that I can get 12ths. Okay, so now we have 12ths. How many of those 12ths are shaded? 1, 2, 3. 3 12ths are shaded. Okay, let's check and see what have we multiplied my numerator by to get 1 times what to get 3? Times by 3. So let's see if we did the same thing on the bottom. 4 times 3. Does that equal 12? Yes, it does. Okay, the last one. What fraction of this pie is shaded? 1, 2, 3, 4, 5 parts out of how many altogether? 5 parts out of 6. Okay. If this pie has been split into 6 equal parts, how many will I need to split each of those sections up into to make 12ths? Right, each section just needs to be split into 2 equal sections. Oops, that's not very equal. Okay, how many of those 12 equal sections are shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of those 12 equal sections are shaded. Let's see if 5, 6 is, in fact, equivalent to 10/12. What have I multiplied my numerator by to get from 5 to 10? 5 times 2, so on the bottom, did I do the same? 6 times 2 is 12. Yes, I did. So 10/12 is equivalent to 5/6. Okay, half of these 8 circles are shaded. So my fraction is 1/2. I'm going to group them in different ways to see if I can come up with 2 other equivalent fractions. Okay, well, like we did before, what if we looked at it this way? And I grouped them into 4 equal groups. So each of those equal groups is 1/4, right? Okay, so how many fourths are shaded? 1/4 here, 1/4 here. That's 2 fourths are shaded. Okay, that's one equivalent fraction. But let's see, maybe there's a different way I could group these and look at them differently so that I have equal groups. What if I look at them individually? How many equal groups can I make then? right? 8 equal groups. And how many of those 8s are shaded? 4 of those 8 are shaded. Okay, let's just check using multiplication to make sure that 2 fourths and 4 eighths are actually equivalent to 1/2. So what have I multiplied my numerator by? 1 times 2, right, gives me 2. Did I do the same in the denominator? 2 times 2 equals 4. Yes, I did. Okay, so now let's check and see. What have I multiplied 1 by to equal 4? Times by 4. So did I do the same in the denominator? 2 times 4. Does that give me 8? Yes, it does. So I have proved that 2 fourths and 4 eighths are all equivalent to 1/2. They would cover the same amount. They would be shown with the exact same picture. Okay, let's see how many equivalent fractions we can write for these pictures. Okay, well, the most obvious one probably is just how many circles are shaded, 8, out of how many altogether? 20. Okay, 8/20ths are shaded. Okay, but what if I look at them this way? I have 2 equal groups out of 3, 4, 5. 2 out of 5 equal groups that are shaded, if I look at it that way. Okay. Is there another way I could have grouped it? What if I do it this way? Groups of 4. Will this work? Groups of 4. Groups of 4. And this is still a group of 4. Okay, so how many groups of 4 do I have? 1, 2, 3, 4, 5. So I have 5 equal groups. Oh, I already have that fraction. 2 of my 5 equal groups are shaded. I've already got that one. Okay, let's try the second one. Let's try how many are shaded all together in this rectangle. 6 out of 12. Okay? Oh, but I could regroup that a different way. I could look at it this way. Well, that's 2 equal groups. And one of my 2 equal groups is shaded. In other words, 1/2. One of my 2 equal groups, 1/2, is shaded. Okay, what if I wanted to look at this one this way? I've got 1 equal group, 2 equal groups, out of, how many equal groups can I make of those? Oh, 2 of the 4 equal groups are shaded. So that would be equivalent, 2 fourths. All right, let's look at one more. What if we don't have pictures and we're asked to write 2 equivalent fractions for each fraction below? Then I just have to remember all I need to do is multiply the numerator and the denominator by the same number. Okay, so in this case, I could multiply by, and keep it simple, multiply by 2. Okay, so if I times by 2, I'd have 2 times 2, I'd have a 4 in the numerator. Do the same thing on the bottom, times by 2. 3 times 2 is 6. Okay, let's do it again. This time let's multiply by 3 on the top. Okay, so 2 times 3 is 6. So then I have to do the same thing on the bottom, times by 3. 3 times 3, 9 on the bottom. Okay, what that means is 4/6 is equivalent to 6/9, which is equivalent to 2/3. All 3 of those are equivalent. Okay, let's try the next one. 7/9. Okay, well, let's keep it simple, keep small numbers, times by 2. If I multiply by 2, 7 times 2 is 14. And on the bottom, I'd have to multiply by 2 as well. 9 times 2 is 18. So 14/18 is equivalent to 7 ninths. What if I do it again? Keep it simple. Let's times by 4 this time. Because it doesn't have to be 2 and 3. I'm just keeping small numbers. It's easier to multiply in my head. 7 times 4 on the top would give me a numerator of 28. Do the same on the bottom, times by 4. 9 times 4 is 36 on the bottom. So 14/18 is equivalent to 28/36, which is equivalent to 7 ninths. And what about this last one? So let's keep it simple. Multiply by 2. If I times by 2, 11 times 2, 22. Do the same on the bottom, times by 2. 4 times 2 is 8. So I have the fraction 22/8, which is equivalent to 11/4. Okay, this time let's multiply by, 6. What's 11 times 6? 66. If I multiply by 6 on the top, I have to multiply by 6 on the bottom. 4 times 6, 24. So 66/24 is equivalent to 22/8, which is equivalent to 11/4. Okay? Now I just want to show you one other thing before our time is up. So if finding equivalent fractions can be found by multiplying your numerator and denominator by the same thing, you also can divide the numerator and the denominator by the same thing. So look back at this example here. 8/20 is equivalent to 2/5. Look at what I've done on the top. 8 divided by 4 gave me 2. So I have to do the same thing here. Divide by 4. 20 divided by 4 is 5. Okay, so it doesn't always have to be timesing. The rule is you multiply or divide by the same number on top as on bottom. Okay? If we do that again, let's see if we can divide the top and the bottom again and get a different equivalent fraction. Okay, so if I have 8/20 and I've divided by 4, let's divide by 2. Can you divide 8 divided by 2 is 4. 20 divided by 2 is 10. So 4/10 would be another one that is equivalent to 2/5 and is equivalent to 8/20. So the rule of thumb is whatever you do to the numerator, whether you multiply or divide, you have to do the exact same thing to the denominator, and you will get an equivalent fraction.